In this video, I will show you how to use interrupt to control LED and switches. Use another driver that we have, LED and switch, LEDs and switch. Right, so we will create the project from the previous IOC. So click in create a new SM32 project from an existing SM32 MX configuration file. Wait for a few seconds, then browse to the previous project. For example, here I will use the projects October 22, 2024, my project 005, because this one is already configured. So click to the IOC file, click open, then untick this one, browse, then go to the folder, okay, then create a new folder, name it to say 006, accept, select the folder, then you can change with EXTI extended interrupt. Click to finish. So first thing first, we need to modify the IOC at the push button or switch for pin PE1, PE4, and PB0. So once the IOC is displayed, so we will change the pin from GPIO input to GPIO extended interrupt 0 for GPIO extended interrupt 1 for PA1, GPIO extended interrupt 4 for PA4, and GPIO extended interrupt 0 for PB0. Okay. It takes sometimes. Okay, right. So go to the PA1, left click to change to GPIO extended interrupt 1. Then PA4 for GPIO extended interrupt 4. And PB0 change to GPIO extended interrupt 0. Then after that, click to the system view, GPIO. Okay, so we can change the external interrupt to trigger on falling edge. That means whenever it is being pressed, then it will interrupt falling edge. And same with the second one, falling edge for A4. Then go to PB0 for falling edge. Because the push button is active low, but you can also set it to falling and rising. Okay, but go to the NBIC, then enable all the interrupt. It's an interrupt 0, click here, 1 and 4, right? Then generate the code, the code. The clock we already configure. All others we already configure correctly. GPIO, and then right, we already set all the PA, PA6, PA6, PA7, and PB6 to open drain, but we set PA5 to output push full. In some way, for the connectivity, we set it already to asynchronous, and then we accept the parameters, the default 115.200, and remember to enable the NBIC. Okay, right. So once we generate the code, okay, then we transfer the file that we require. So the first one that we require is the serial com. Select all, click to switch by hand pressing Control. Use SysTick. Then we need another one, let. Then by pressing Control, move all them to include, for example. Then move all the C file to into source. Then as standard practice, open up the serialcom.c, copy that one character. You can increase this one to 1000, for example, if you like. Copy it, right? Then go to main and place it in the PV, MPV for global as external. Then after that, include all the file. So we have the first one that we have is, say, include control space, double quote, user tick, enter, pound, include, double quote, I think we have Sharecom. Then we have include, we have let. Then the last one we include, we have Swiss, right? Then I suggest you do it at the from bottom up. So from bottom up, you can set the, okay, just to look either the code is working or not. That transmits text, double quote, /n/r, right? Extended EXTI, double quote, lets and switches with extended interrupt, semicolon, and then set SysTick to, say we're going to use 2, let is 2 for example, per moment. Then we can start for the outputs, for the outputs. So we can see that if get SysTick only, okay, only. So say we use number 1 and we reserve zero, reserve 0 for our interrupt later. Okay, then we can start writing code to upload the data. So I just copy the previous code. Right? Go to the previous code. Main. So I just interested with the data here. Right, then I also interested with the data here, the code here. Okay, this code actually just display the pattern. So we can see the pattern instead of we look at the board later. We can see the pattern correct, right? Display correctly. Then we discuss the code later. Then we interested with this. Right. Alright, so if I run this one, I need the you know the index timer out. I need mode, yeah, I need mode here. So I can copy this one, right? So we can see either the code is working or not by looking at it. So say I set it to number 3 for the case number 3. Right? Case number 3 here. So you can see this one later on and just compile it. Then go to the Keratum. Okay, and so this is stealing Visualcom. Click OK. Then set the serial port to 115 to 0 about bit per second. You can increase the size, font size. Then once it's okay, then now you can run it. Okay. To run. So this is the way how the code being written from uh, bottom to bottom up, right? So we start from the bottom, not from the top, right? Not from top. So we see let and switches we extend interrupt 001, 0011, 001. The pattern here, same with the pattern here. The pattern that we have. we have here. And same. All right, next we go to, so we can assume that all others are working if you change the mode, right? Change the mode. So now we need to include the as an interrupt callback to handle the interrupt. All right. One way you can go, you can. There are many ways to do the code. Right? But the simple way is just set the mode as the global. So move it here, copy, cut, and place it here. Say when we started, we set it to when it starts, right? Set it to 0. Okay. So whenever this is timeout, then we will check either the mode is, and so we can set another default, maybe default. It says SysTick, right? Tap out to say to 500, 5,500, say it's okay, no problem, and then break. Okay. All right, now we go to the standard STM32 F4XX hard driver. Open it up, expand source, go to GPIO, click to open it up, and then click to window, show view, or line. So from here, click to hold GPIO as an interrupt callback. Okay. We're interested with this, copy it. I think you know it already. We go to the main, then place it. Place it somewhere here. Maybe I can place it here. Now, this callback will be called whenever there is interrupt generated either by any of that 3 lines. So we can say that if that GPIO underscore pin is equal to GPIO underscore pin underscore 1. So this is as an interrupt 1, which is means what's generated when we press PA1. Okay. We can write down in the one if GPIO underscore pin equal GPIO underscore pin underscore 4. Okay. This is generated by PA4, and the last one that we have is if the interrupt is from GPIO pin GPIO 0. This is VB0. This is from B0. This is from A4, which is at S1, S2. This is at A1, at S1. Okay, so here whenever it's interrupt, then we will change the simple push button. Then we change the mode. Okay, depends on on the push button at the bottom later. Okay, so we need the variables to hold the switch. So we can say SW1 UINT8 underscore T SW1. Then we can have UINT8 underscore T SW0. So this one make it become static. Okay, then sure, whenever the push button, this push button is being pressed, then we sample the pin. Sample the pin, right? So we can check if, right? Or we can go straight to if GPIO underscore pin, or we can read the pin, right? We can read the pin. If HAL underscore GPIO underscore read, we read from GPIO A pin underscore 1, then we will then SW1 SW0 we all with 0, oh, sorry, 1, right? Else we will clear the bit, SW not, we clear the bit 0B 110. We want to clear the last bit. Same thing here. Actually, we add it with 0B 001. Okay, so that's the pin. For pin A1, copy this one. So change this one to 4. A4. This one change to 10. This one change to 101. Okay. And then we have another one here, the last one. Control B. Change to B. Change to 0 because B0. Then this one change to 100. This one change to 001. Okay. So here we 011, we clear the third bit or the bit 2, B2 of SW not. I'm sorry, we should go back to use the driver, the IOC, click to GPIO, set all the SN interrupt to SN interrupt if rising and falling, right? That means it will interrupt it whenever we press and we release the push button. Okay, regenerate. Good. So whenever it's interrupted, what we do, we copy, right? We copy the previous SW1, SW node, copied it into SW1, right? Okay. Then after we read the new SW node, then we make a decision, right? Then we make a decision just like previous, right? Then we can say that if SW1 is equal to 0, and SW1 is not equal to SW0, then we start to check, right? So we can write down using switch. Right? We intersect with SW0. Case 0. Oh, sorry. Case 1. Case 0B 001 is being pressed. Then we change mode to modes is equal to mode equal to 1. Then say we want to change the set the index. So set index equal 0. For the reason index also must be set to global index. Okay, mode index. Then okay. So we can write down here if mode not equal to 1, then we can say that mode equal to 1, then index equal to 0. And I think that we can do is we terminate the get SysTick only here. The tick 1, we terminate it by using the activate. So we activate the SysTick 1. Activate it. So now we can copy this one. So we have the second one, if that middle being pressed. This one if the this is one way. Another way we can do is okay, no problem. This is one way. Another way we can do is we can just close this one. Then just check if that's from GPIO 1, or the interrupt is from this, okay, or the interrupt is from here. Okay, so what you do is just if that's from this, then we read the SW0, right? Then SW0 is equal to from get switch. Oops. Get switch. We should have the okay switch. So in the case we need to change this one to int, because this one return int8. Okay. So Swiss, good, from Swiss. Then after that we make a decision based on that. Okay, so copy all this. Right. So that's simpler, simpler way of doing it. Okay, from here we can see that if that interrupt is from GPIO pin or, or this or this or this, then we will sample the new push button, the new status of the button, then make use of that to activate, to direct our mode, and to control our mode. So I delete this one. Okay, so all right, another things we have the bounce, the bounce. So how to solve the debounce? We can, what we can do, we can set it to, and the debounce we can set if get SysTick time elapsed, right? Number 0 of gap of say 50 millisecond. Then we allow the sample, right? The sample again. We can put it inside here, right? I mean, we can put it here if you like. Okay. Okay, so this is good. I mean, whenever interrupt is happen, triggered, then the the processor will check and check either it is from these 3 pins. If that from these 3 pins, then it will check either if it is already more than time elapsed. If more than time elapsed, it's allow the interrupt. So it will read and then process it, as usual. Okay, so compile, or you can run it directly. Okay, now I press the button. Okay, press second middle button. I press the right button or S3, middle, okay, left button or S1. Sorry. Okay, so we can see that how I use the interrupt, right? I use the interrupt to sample the push button. So again, this first one in the callback and callback, whenever the interrupts is triggered either from this 1 to 3, so the processor will check and either the time is already elapsed or not. If elapsed, then it will allow the sampling of the push button. Then from that it will decide which mode that to be to be handled. For example, here if you press S1, then it will generate change mode to 1 if the previous not 1. And similar to here, if you press S2, then it will change mode to 2 if the previous mode is not 2. And also for the S3, right? Yeah, for S3. Then I make the mode becomes global. Another thing that you can see here, I set the SW node as static, because I want to hold the value. Right? I want to hold the value. And then here we have a display pattern is checking the picture with positions the position of 1. So it will add, for example, if that one at the position at bit 0, then it will add 1. If at position 2, then it will add 10. Position 3, 100, and this is at position 1000. So I use shift left and right, to check the the stated or conditions or value of that array. And then I print the pattern here. And then in the code, I just run the one thing. I use tick 1 here that check the mode. Right? If that's 1, then I will update, and I will update uh, the display each 300 millisecond. Right? So I use set SysTick the out, and then increase the size, the index. If the index more than the size of the elements of the array -1, then we change index to 0. So same to all, right? Same to all. Okay. So I think it's very simple code for you to exercise. Please do it. Okay. So again, I use the 4 files here. Let's switch, use a tick and circum 1. Bye bye.